Okay. Will I be able to hear questions being asked? Hello, Jakob. Okay.
Hi, Nick. I'm sure you cannot see the crowd. You're going to see me, but the crowd sees you on the big screen.
Hello, everyone.
Hello.
Oh, I hear them. Wonderful. That was my question was, am I going to be able to hear people ask questions? So
yeah, you will. If not, I will translate it. But so with no further ado, Nick, the stage is yours.
All right, marvelous. All right, so let's go. Let's get going. I know it's really late for all of you over there. So what I'm going to do is I'm going to get through as much as I can in a reasonable period of time, and then I think what we'll do is we'll do a fuller session, you know, where we really deeper dive. This is supposed to be a deep dive. We'll do a deeper dive, and you can all join me for that. So let me go ahead and share my screen, which I will do if I can find the right button. There we go. Okay, share. And there we go. Can you see my screen? Yes. All right, marvelous. I heard somebody say yes, so I hope they're not lying. All right. Now, so as we were saying, so today we are going to talk about Retrieval Augmented Generation, or RAG. This is the thing that everybody's talking about. So what we're going to do is we're going to talk about what it is and how it works. So very quickly, who am I? I'm the Senior Director of Product Management and the head of the AI practice here at CloudGeometry. I'm also the author of Machine Learning for Mere Mortals. That is what I do. I take complicated topics and I turn them into something you don't need a PhD to understand. So hopefully that's what I'm going to do here today. I know Annie also talked about the LFAI and Generative AI Commons. I also work with the models and data and education and outreach work streams, helping to co-lead those. And I represent the Commons to the FinOS Open Financial LLM work group. All right. So let's talk about what we're going to talk about here today. So as I said, we're going to talk about what RAG is and why it matters, why you should care. And then we're going to talk about how does it actually work, because it doesn't do any good if you don't understand what's going on behind the scenes. Then we'll look at actual coding of it, you know, not a toy example, but real stuff. And then hopefully we'll have time to get into sort of more of the optimization and tuning aspects of it to get better results, even better results, I should say, because RAG immediately is going to give you better results. All right, so what is it? Why you should care? So let's start out with a plain old LLM. So in this case, user asks a general question. LLM processes the question. It goes through all of these things that it knows based on, all the data that it's been fed, and it gives you a literate answer that sounds like a human put it together. Great. That's terrific. That's what it's supposed to do. But sometimes if you have a more specialized question, maybe not so much. So the LLM might process the question, it doesn't find an answer, and then maybe it says it doesn't know the answer, or maybe it gives you a hallucination. And in case you're wondering, I was wondering about this. Why do they call them hallucinations? They're things that the LLM is absolutely sure of that are completely fictional. They're just not correct. So hallucinations are what we're trying to avoid. So what if we could provide extra information in this kind of middle step. So the user asks a specialized question, we do some pre-work to help find an answer, and then we let the LLM synthesize a result to give us that literate answer that sounded like it came from a human being, like we were talking about before. That right there, that is what RAG is all about. It's that center piece. And the reason that we use it is we want to get better answers. And there are lots and lots of use cases where this comes in. So, I mean, the simplest thing would be something like fine-tuning answers, just to get a better answer to the data, to the question that was asked. Or in the case of very specialized questions, sometimes you really need to do something complicated in order to get the right answer. You could even insert an agent into that process. There's specialized information that you're giving back, like code generation or language translation. These are times where you may not want to rely on the statistical things that that the LLM does to give you a result. Sometimes it's a matter of you want to give it specific information to act on. For example, you might have an LLM that understands medicine, it understands treatments, it understands diseases, but in that intermediate step, you might give it a patient's specific medical history and test results, and then feed that into the LLM, which could then give back treatment recommendations that are specific to that person. It would be the same thing for personalized recommendations. These are things that are specific to that person. So there's a lot of different ways that you can use RAG, a lot of different reasons that you might want to use it. So the question is, how does it actually work? It's great that you can do it, but how do you do it? So I'm going to thank Bill Williams for this very simple toy example. So imagine for a moment that you have a corpus of documents. We're just going to look at the pre-work section here for a second. Forget about the LLM. So let's say we have just a collection of suggestions for activities of things that you can do. And all you want to do is you want to ask the user, what's a leisure activity that you like? In this case, well, I like to hike. And it's going to go ahead and say, all right, I want to get a return response, which is going to basically compare this user input to the different documents using a function of similarity. The actual function here is irrelevant to what we're doing. But the important point is we're saying, all right, let's find the most similar thing and return it. So if we were to go ahead and say, all right, now I've got that code set up here. So here's my list of documents. I know this is a little bit hard to read. I apologize. And I'm going to say, all right, I like to exercise. If I went ahead and ran that, so I'm going to come over here. I'm going to say, all right, Python manual.py, because that's the script. Okay, well, it says, well, if you like to exercise, take a leisurely walk in the park and enjoy the fresh air. That is the actual sentence that we had in the corpus. That's great. Terrific. Easy enough. Now, let's say we want to go ahead and integrate this with an actual large language model. All right, so we say, all right, we're going to take some requests. We're going to use some JSON. This ellipsis here is the code that we already had for the most part. So we've got your prompt, your leisure, what's the leisure activity that you like? We've got the user input. In this case, it says, I like new things. We'll look at the code and see what it actually says. But what we're doing is we're saying, okay, we can get back that document that we got before, the document being the sentence. But before we actually send back a response, we're going to build a prompt that we are then going to send to the large language model. So here's the prompt. You're a bot that makes recommendations for activities. You answer in very short sentences and don't include extra information. Whoop. This is the recommended activity. That's what got returned in the last step. The user input is, and then compile a recommendation to the user based on the recommended activity and the user input. So the LLM is synthesizing this information based on all of its knowledge. So in my case, I'm just using Ollama to run Llama 2 on my laptop. So we're not doing anything fancy. We're just incorporating that information into the prompt, and then we're sending the prompt off to the LLM and getting a response back and printing out the response. So let's see what happens when we do that. I've got all my code, and let's see. It's the user input in this case is I like to exercise. So let's see what happens when we run it. Come back over here. Python manual LLM.py. It's going to take a few extra seconds because it's loading up the large language model and it's doing all of that processing. So there we go. So we have, so now we have our prompt. So we got back our original recommendation, take a leisurely walk in the park. Now, here's what we got back from the large language model. Sure, here's a recommendation for the user based on their input. Consider incorporating your love of exercise into your walk by adding some light jogging or jumping jacks into your route. This will not only make the walk more enjoyable, but also provide additional benefits for your physical health. All of that came from the LLM. And we were able to get that because we were able to provide it with that additional information. So if we go, that right here, that pre-work to find that answer to feed to the LLM, that is the heart of retrieval augmented generation. Okay, right in here, that's step 2. So what can you do there? Well, you can literally do anything. You can put in something that, you can put in one of those talk with PDF sections. You could read from a SQL database. So for example, you could have a SQL database that has order status, that you could pull the user's order status and then have the LLM have a conversation about the order. You could read from a vector database. If you're here, I don't need to explain to you what a vector database is. You can follow business rules, etc. You can call out to an API, to another system to find out other information. You can introduce a full-blown agent, as I was saying before. You can do anything in that step. It doesn't, there is no restriction on what you can do in that sort of pre-work step. Now, that was kind of a toy example, what we saw before. So fortunately, if you're going to do this for real, you do not have to code this by hand. Okay. There are lots of tools out there. Some of the, most commonly known are Llama Index, LangChain. I'm going to show you Llama Index here just because I just picked one and that was the one. Again, I'm running Ollama on my machine so that I can run Llama 2. By default, Llama Index uses OpenAPI, so I'm going to say, no, don't do that. Use Llama 2, and we're going to use a local embedding because everything is here on my laptop. And then all we're doing is we're saying, all right, I want you to read all the files that are in the data directory. I want you to load all that data and create this corpus of documents. And then I want you to create a vector store index from those documents. Okay, so this is a fairly complex thing that we're doing, and we're doing it with just a couple of lines of code, which is great. Then we're creating a query engine from that index, and then we can send a query directly in. So I just made up a nonsensical thing. I said, all right, well, what color is the diamond baseball? Okay, There's no such thing as a diamond baseball. I just made it up. So let's see what happens if we go ahead and we try and do this. Now, in my data directory, all I have is one empty document. There's nothing in doc1.txt. I just had to have a directory there. So if I say, all right, Python app.py, because that's where the code is. I already loaded up. I loaded this up a little bit earlier so I could pre-warm it so you didn't have to wait for a couple of minutes while it, downloaded everything and ran everything. But it's still going to take a few seconds because, Llama 2 is not small. But it'll give us back a result in a minute. So it says the diamond baseball is purple. Okay, well, there is no such thing as a diamond baseball. Okay, if I ran it again, let's see what it says. Okay, it's just guessing at this point. Because again, there is no such thing. So we'll give it a few more seconds. And of course, when you have a whole crowd of people looking at you, time just expands, doesn't it? So while we're waiting, did you guys have a good day? Oh my goodness gracious, it timed out. So what's that? I couldn't hear what you said. I hope you said you had a good day. All right. Good. Well, now it says the diamond baseball is blue. Obviously, it can't be all of those things. So let's go ahead and I have a file here, vi data1.txt, about the diamond baseball. So let's go ahead. I want to say the thing is the diamond baseball is, let's say it's green. Okay. All right. Now, and then I'm going to go ahead and I'm going to move data 1 to the data directory. All right. Now, let's try running this again and see what happens. So now I'm going to run it. Very long time to figure out the color of the What was that, Yakov? Can you repeat that? I couldn't hear it.
Yeah, it is a very long time to figure the color of the baseball ball.
That's true. And actually, it still got it wrong, actually. Well, that's the first time that's happened. There we go. The diamond baseball is green. Now, here's an interesting thing to keep in mind when you do this. If you're not careful, you will be training the language model. Well, that's interesting that it's now it's screwing up. The demo, apparently the demo demons have gotten me. But you can inadvertently wind up training your large language model. So for example, I ran this many times in putting this whole thing together. And then the large language model kept giving me back the value that I had given it, even after I took the data away. All right, so let's go back to what we're doing here. So this was a very, very simple way to do this. But you have a lot of control over the parameters that you use, which is great because you can optimize and tune this as much as you want. I'm going to run through these very quickly because I know that I'm keeping you from drinks and socializing, and I wouldn't want to do that. All right. So some things that you can do on the back end, you can look at the sort of chunk size. So for example, you can break it out by sentences or, by 4-word tokens or whatever. The smaller the chunks, better for question answering because you get a more specific context. For summarization, you would want more like larger chunks. You can also do things like overlapping the chunks, as you can see here with the sort of gray here to get better context. The idea is to get just the right amount of context in it. You can play around with the embedding model, make sure that the data that you have is most appropriate to the model that you're using. Some can be fine-tuned, some cannot. In general, the higher the dimensionality in your embedding model, the better. But again, depends on your data. You can add metadata. So for example, in addition to adding all of your documents into a vector store, you might also add things like, the date or a file name or something like that that you could then filter on later to help you get a better result. You can use different indexing strategies. For example, you can create multiple indexes in order to get a better result for different searches. Instead of using k-nearest neighbor, maybe you want to use approximate nearest neighbor. There's a bunch of different algorithms that you can use. You can use what they call small to big. So you might find the relevant chunk to the answer to the specific question that you're answering, and then sort of move outwards. So for example, you might find the sentence where the text appears, but you're looking for a much larger question. So then maybe you move out to the paragraph where the sentence appears, or even the chapter or book where that appears. So that's another way to get better context. You can also do what they call re-ranking. Similarity is not always the best way to judge relevance, particularly when there are, negatives involved. So if I say something like, what's the best way for me to not fall on the ice? If it's giving me instructions for fall on the ice, that would not be good. Also, when you do re-ranking, you get around a weird problem called lost in the middle. With these large language models, a weird thing that happens is that the items at the beginning of the list and the items at the end of the list get more attention, and the items in the middle of the list don't. So while normal human ranking would say, give me the best at the top, the worst at the bottom, in this case, actually you want the worst in the middle, because you don't want to see those. So that helps to get rid of some of these garbage responses. But the best thing that you can do probably is query transformations, because remember, what you're doing is you are creating a prompt that goes into the large language model. So you can do things like rephrasing the prompt. You can even feed the original question to the large language model to get a better prompt. You can create subqueries out of the original prompt. The hypothetical document embeddings, these are things where you sort of ask a question and then you get back a bunch of documents, and then you use those documents to ask better questions and so on. But it's all a matter of prompt engineering to sort of give you the best answer. All right, so that was a very brief look at all of that. I'm 1 minute over what I said I would be, but anybody who's interested in a deeper dive, feel free to send me an email, nchase@cloudgeometry.io. I think we're probably going to put something together, and we will get you information on it. Do we want to do questions, or just to have people send me questions, Yakov?
So you can stop sharing your screen so people actually will see you.
Okay.
Cool. Any question, guys? Any questions? Yeah, Jonathan, go ahead. I will translate it for Nick. You can see only me.
Hello, it's Jonathan. I work for Wikimedia. We're building a writer ourselves. I'm curious if all the code you're working on stores or runs the llama and the embeddings locally. And my statement, do you have like an A100, or are you for-bit quantizing the models? Like, what's the process behind the scenes?
I couldn't quite hear what he was saying. You're going to have to repeat it for me.
Sure. So the question is, can you just help me?
What's the process behind the scenes if you're loading the Llama 2 locally? If you have a large GPU, or does this use?
I don't. No. I'm actually running this on. I'm actually running this on a bog standard no GPU. Well, it does have 64 gig of RAM. It's just a plain old, HP laptop. That's it. Nothing special. I thought I wasn't going to be able to do it, but Ollama makes it very simple.
But it's Llama Center.
It's Llama Center.
So
Say again?
If it's Llama 7.
It's Llama 7,
I'm a 7.
The size of the model.
the size.
Oh, the size. Yeah. It's Llama 7. It's 7B. Yes. It's Llama 7B. Yes.
Any other question, guys? No. Nick, thank you very much. I wish you could be here with us. Thank you
I
for the
wish I
session.
could too. But thank you all very much, and have a great time drinking and socializing. Thank you all. Bye bye.